The James Webb Space Telescope has provided us with an incredible new window into the universe's furthest regions, and its most recent discoveries may be upending everything we previously believed to be true about the universe. The Big Bang Theory has been the most widely accepted theory among scientists to explain how the universe came into being for many years. However, recent findings imply that there may have been an odd, even frightening entity existing before the Big Bang. Scientists studying physics and astronomy all across the world are now frantically trying to modify their conceptions of the universe's origins in light of these discoveries. What precisely has the James Webb Space Telescope discovered then? How does it alter the way we perceive the cosmos? Above all, what does it signify for cosmology's future? Stick around as we explore the most recent discoveries that are changing the way we perceive reality. The birth of the universe, the Big Bang. Let's first review the conclusions of the Big Bang Theory in order to comprehend the importance of these recent discoveries. The general consensus has been that the universe started with a tremendous explosion known as the Big Bang some 14 billion years ago. An incredibly dense point, known as a singularity, once contained all the matter, energy, and space that we can see around us today. This singularity quickly expanded to create the universe's stars, galaxies, planets, and familiar concepts of time and space. According to this theory, the Big Bang marked the starting point of time itself, not simply the universe. Time did not exist, hence there was nothing before the Big Bang. Or did it? The discovery of cosmic expansion. In the 1920s, a paradigm-shifting revelation was made. Galaxies are moving away from us, with the farthest ones doing so more quickly. Edwin Hubble's discoveries provided compelling evidence that space is getting bigger, and that objects are not the only things moving through it. The Big Bang Theory, which holds that the universe originated from a single, incredibly dense point, was based on this discovery. But the more we learn about this expansion, the better we come to understand that the Big Bang might not actually be the starting point. Retracing the evolution of the universe to that singularity presents important questions. What preceded this occurrence? Was there a previous universe, a priori space-time structure, or perhaps a separate set of fundamental laws? These inquiries test the boundaries of our knowledge and raise the possibility that the origins of the cosmos are more intricate and enigmatic than previously believed. These long-standing riddles are finally becoming clearer due to the discoveries made by the James Webb Telescope. Einstein's bubble theory. With his general theory of relativity, Albert Einstein transformed our knowledge of space and time and profoundly altered our perception of gravity. Gravity is perceived as the twisting and warping of space and time due to the existence of mass and energy, rather than as a force operating at a distance. Using the metaphor of a bubble to help picture this is helpful. We live on the skin of this bubble, which gets bigger as the universe grows. However, Einstein's concepts also suggest the possibility of the existence of other bubbles, or universes, in addition to our own, which is even more astounding. This serves as the basis for the multiverse theory, which holds that every bubble symbolizes a distinct universe having a distinct set of physical characteristics and laws. This theory suggests that the Big Bang might not have been a single, isolated event, but rather the result of ongoing universe formation in a cosmic bubble bath. This perspective, which holds that our universe is but a tiny portion of a much broader, more complicated reality, drastically broadens our comprehension. But there are important questions raised by this multiverse theory. What prompted the formation of the bubble that contains our universe? Are other universes going through processes comparable to ours? And why is our universe expanding in the manner that it is? These queries challenge the boundaries of our knowledge of cosmology today and allude to unsolved mysteries. Inflation, a rapid expansion of space. In particular, the idea of cosmic inflation explains why the cosmos seems uniform and flat on a wide scale, resolving numerous important problems with the original Big Bang hypothesis. The universe is said to have expanded rapidly in the instantaneous period after the Big Bang, stretching out any wrinkling or abnormalities. The comparatively equal distribution of galaxies and the appearance of flat rather than curved cosmos geometry could both be explained by this rapid inflation. The universe changed into a slower, more measured expansion as the unexplained energy causing this inflation was released from its confines in the fabric of space. Matter might start to develop at this point, giving rise to the planets, stars, and galaxies that we see today. However, this neat picture is being called into doubt by recent observations made with the James Webb Space Telescope. One finding of the telescope is that the cosmos is expanding at a non-uniform rate. Different parts appear to be expanding at different rates. This finding complicates the previously accepted concept by indicating that there may be a factor impacting the universe's growth other than dark energy or inflation. Scientists are being forced by these results to reevaluate the specifics of inflation and the extent to which it can explain the early cosmos. The James Webb Space Telescope. The James Webb Space Telescope, JWST, which was launched in 2021, has grown to be one of the most significant instruments in contemporary astronomy due to its unparalleled capacity to take precise pictures of far-off galaxies and examine the universe at wavelengths longer than visible light. Astronomers are now able to travel across time and space more thoroughly than in the past. By doing this, Webb has shed light on the early cosmos and altered our perception of the formation of galaxies, stars, and other cosmic structures. The universe seems to be growing at various rates and in multiple directions, which is one of the telescope's most unexpected findings. This finding has the potential to seriously undermine our understanding of cosmic expansion. The standard model of cosmology and inflation theory anticipated that the universe's expansion was similar in all directions, and this assumption has served scientists well for decades. It was previously believed that this homogeneity resulted from the inflationary phase that followed the Big Bang, which eliminated any abnormalities. However, Webb's research indicates that the rates of expansion are not constant, which raises the idea that unidentified forces or events are affecting the universe's expansion. This finding might indicate novel physics beyond existing theories, which would need a reassessment of our knowledge of the universe. Uneven expansion. A new mystery. Deep questions concerning the forces shaping our universe are raised by the finding that the expansion of the universe varies at various rates in different regions. Dark energy, the enigmatic force that makes up around 70% of the universe and is assumed to be responsible for its fast growth, is one of the main contenders for creating this uneven expansion. But if dark energy isn't expanding equally throughout space, it could account for why certain areas expand more quickly than others. This would imply that dark energy may be more complex and changeable than we presently think, maybe exhibiting regional variations in power or behavior. However, it's not impossible to imagine that something even more bizarre is at work. If dark energy isn't the cause, then space's expansion could be influenced by completely unidentified forces or occurrences. This may indicate a gap in our knowledge of fundamental physics, or suggest the existence of new particles, forces, or dimensions that we haven't yet discovered. Above all, these results raise doubt on the central concept of cosmic inflation. Now that the early universe has been smoothed out by inflation, how do we account for the differences in expansion rates? Is it possible that inflation was not as severe as previously believed? Or did inflation happen unevenly, leaving behind regions of space that expanded at varying rates? These findings imply that the origin of the universe may be a more intricate and nuanced tale than previously thought, which is forcing cosmologists to reevaluate the basic tenets of cosmological theory. What existed before the Big Bang? Thousands of odd red dots have been detected in the deep field photographs taken by the James Webb Space Telescope, adding to the mystery surrounding uneven expansion. These dots initially gave scientists the impression that they were far-off galaxies, but their traits and behavior contradict what is known about early galaxies. Since these objects don't cleanly fit into the theories that have been developed, it's possible that there were previously undiscovered kinds of celestial bodies in the early cosmos, or possibly whole new phenomena that we haven't fully understood. The idea that the cosmos might not have truly begun with the Big Bang is possibly the most significant implication of Webb's discoveries. Alternatively, it might have marked a change from a previous state, a pre-Big Bang period subject to various physical forces or rules. Cosmologists are forced by this novel concept to reconsider the universe's origin and explore possible prehistories of space and time. Which circumstances or events might have existed prior to the universe's sudden expansion, and how would they have altered our perception of reality? The solutions might completely transform the discipline of cosmology and pave the way for a hugely exciting new area of research. Theories of a pre-Big Bang universe. A number of fascinating theories have been put forward to explore the possible existence of a pre-Big Bang universe. The cyclic model of the universe is one such theory, postulating that the cosmos experiences endless cycles of expansion, like the one we are presently experiencing, interspersed by contractions. According to this theory, the Big Bang was actually the rebirth that occurred after the collapse of an earlier universe, not the actual beginning of time. Each cycle would erase all traces of the previous one, resetting the current one to start anew. Another intriguing idea is the multiverse hypothesis, which suggests that our universe is merely one of many universes existing within a vast multiverse. Two universes within this multiverse may have collided or interacted to cause the Big Bang, and these universes may operate according to different physical laws and constants. This opens the possibility that the creation of our universe is just one example within a much larger and more complex cosmic landscape. A new era of cosmology. The James Webb Space Telescope has only just begun to yield discoveries. As scientists continue to analyze the data, they are becoming more open to the idea that our current understanding of the universe is incomplete. The possibility that something existed before the Big Bang is no longer considered a fringe theory. Cosmologists are starting to take this notion seriously. If these new discoveries are accurate, our understanding of the universe, its origins, and our place within it may need to be drastically redefined. The universe is far more mysterious than we ever imagined, and the answers to these puzzles could change the field of cosmology forever. The discoveries made possible by the James Webb Space Telescope are both mind-blowing and unsettling. They have provided us with a glimpse into the unknown. It's clear that the universe is not what we once believed it to be, and the discoveries in the coming years may have the potential to rewrite science itself. If you found this video fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Your engagement helps us dive deeper into the mysteries of the cosmos.